Welcome to the 5G mmWave Developer Kit Lab Sheet 1. In this section, we'll dive into the concept of what is the link budget. The link budget is the term used to evaluate the received power at the receiver. It points out all gains and losses from transmitter to receiver. It includes the losses from connectors, cables, and other RF components in the communication chain, gains provided by antenna, amplifier, propagation loss, etc. The link budget is an important parameter. It can help engineers evaluate and design the communication system under the target distance according to the receiver sensitivity. The sensitivity is an important indicator for a communication receiver, which means how low a signal can be captured. In other words, the sensitivity will affect the wireless communication distance directly. Calculating the link budget is crucial for designing effective wireless communication systems over the required distance. Engineers must evaluate the link budget to build robust wireless systems. The following equation and diagram represent the link budget. To build the link budget, you must know the gains and losses of all components and free space path loss under the communication link. You can calculate the path loss using the below equation, where d is distance, lambda is the wavelength, f is operating frequency, and c is the speed of light. So, you just need to confirm the gains and losses of RF components from the developer kit. Let's proceed with this chapter practically. Firstly, ensure you have all the necessary equipment ready for Lab 1 as per the course instructions. Alright, let's break it down step by step. Start by connecting the power adapter to the PLO. Next, attach the power detector cable to both the power detector and your computer. Then, install the attenuator onto the output end of the PLO. After that, grab a 2.92mm to 2.92mm adapter and connect the attenuator to the power detector. Now, open the web version of TMYTEK Lab Kit and click on Device Control. Then, select the power detector icon to open the data screen. Next, locate the read method and choose Continuous, then click the Read button below. Now, you've got your data. Keep a close eye on the power readout displayed on the TMYTEK Lab Kit. Remember to jot down these power readings for future reference. Step B. Replace the 2.92mm to 2.92mm adapter with each of the 440 GHz RF cables provided, one at a time. Connect each cable individually, ensuring a secure connection. Then, closely monitor and record the power readout displayed on the TMYTEK Lab Kit for each cable connection. Step C. Now, let's integrate the power splitter into the setup. Place the power splitter between the attenuator and the cable, ensuring proper alignment. You'll need the 2.92mm to 2.92mm adapter to connect the attenuator to the combiner port, as indicated. Once connected, closely monitor and record the power readout displayed on the TMYTEK Lab Kit. Remember, since the power splitter is a 1 to 2 power splitter, you'll need to unplug and re-plug the cable into the other port to monitor and record the readout as well. Keep a keen eye on these readings for accurate data analysis. Step D. Reverse the power splitter into a power combiner, monitor, and record the power readout. Then, as above, you need to unplug and re-plug the cable into the other port to monitor and record the readout as well. Step E. Replace the power combiner with the amplifier. Please use a DC power supply to provide a plus 12 volts DC for the amplifier. Be sure to note that the longer pin of the amplifier is for plus 12 volts, and the shorter pin is for GND. Then, monitor and record the power readout. At this point, you have obtained numerous measurement data. The test results are only for reference. They may differ depending on the developer kit or the conditions. Table 1 is a reference measurement result. To obtain the individual gain and loss, we need a known value to introduce into Table 1. According to the test report of the adapter, the insertion loss is approximately minus 0.28 decibel, as indicated in Figure 1. Therefore, by subtracting it from the measurement results of Table 1 combined with PLO, attenuator, and adapter, we can obtain all the monitoring results in Table 2 and determine the gain or loss of the relevant components. Next, please continue with Lab 2 exercises. You can use these parameters to calculate the link budget with different setups.
Remember to subscribe, like, and ring the bell.